Okay, in this video we're going to go ahead and do a two-sided significance test. My students were wanting to see one of those. So I created this problem just looking up some data on the proportion of students who use marijuana. So according to the National Youth Risk Behavior Survey, the YRBSS, in 2013, the proportion of 9th through 12th graders who ever used marijuana one or more times in their life was 0.407. Jane wanted to know whether the national results hold true in her large urban school in Colorado. Jane surveys a simple random sample of 150 students from her high school. She gets responses from all 150 students, and 55 said they had used marijuana one or more times in their life. What should Jane conclude? So what can we conclude from that? Well, first off, let's state our null and alternative hypothesis. So in this case, our null hypothesis is where P equals, we're going to assume no change. We're going to assume that her school is the same as the national average for right now. We're going to assume that's true. The alternate is we just want to detect a difference in those. You know, is it different than 0.407? We don't necessarily care whether it's high or it's low. And so we set the probability that it does not equal 0.407. And so there's your null and alternative hypothesis. Okay, so we'll define P and the alpha level. So P is the proportion of students in Jane's school who say they have used marijuana at least one time. So there's P. And then alpha level, just for the simplicity of this, we're just going to let it be equal to 0.05. That's our significance level, just since this is an introductory study anyway. So what type of test should we run? Well, this is a one proportion z-test. So one prop z-test is what you're looking for if you look it up on your calculators and that kind of thing. So once you decide on the type of test, you need to check the conditions for those tests, for that test, and make sure it's met. So one proportion z-test, is this ramble? Is this random? Yes. Jane collected surveys from a simple random sample of 150 students in her school. Is it independent, or sometimes called the 10% condition? Here we check to see that the samples of 150 is less than 10% of all students in Jane's school. Since her school is a large urban school in Colorado, it will have more than 1,500 students in the entire school. So we pass that. And then large counts, or can we use the normal distribution or z-score in this case? 150 times 0.407 is equal to 61, and 150 times 1 minus 0.407 is equal to 89. And both are at least 10, so we can use the normal distribution to find a z-score and a p-value. So we've passed all of our conditions. So next things coming here. So calculate the test statistic and use a z-table to calculate the probability or the p-value. So the test statistic is the z-score, which is, if you remember from the last video, p hat minus your initial p divided by the standard deviation, which would in our case would be our initial p times 1 minus p, all divided by n. So just throwing in the numbers, it would be p hat, which is 55 over 150, that decimal, minus 0.407 divided by the square root of 0.407 times 1 minus 0.407 divided by this 150 from her sample. So if you solve all that just to kind of speed it up, and if you want to check me, you sure may, it's going to be negative 1.01 approximately. So we can go ahead and calculate if you've got a Z table nearby, you can look this thing up. And so if you notice, we have a one-tailed Z table here. And since we're doing a two-tailed test, we're going to have to double whatever this probability is to catch the other side as well. And so our p-value is negative 1.01. So if you look here, and I'll grab a little marker, so negative 1 is right here, following that, and 0.01 is this column. So it looks like we're going to double, whoop, I can't draw a circle very well, we're going to double 0.1562. So this means we have, if you double that, our p-value is approximately, and I'll stick that in here, p-value is approximately, and I shouldn't put p, we should put p-value, is approximately 0.31. So I'm going to show you again in this video how to use GeoGebra to do this. So we'll go to geogebra.org, click on Start Creating, and we're going to go down here to Probability. And we're going to choose Statistics. Let me pull this over. And we want to do a z-test of a proportion. And our null hypothesis was 0.407. I didn't register my 0. There we go, 0.407. It's already selected the not equal to, so for the two-tailed test. We had 55 successes out of 150 students, or 150 surveys. 150 or 55, I guess, that use marijuana. And so if you check that, then we have a p-value of 0.31, and it has 4.7. So we had some rounding errors when we were using the table, and I also rounded the z-score negative 1.01. So you can kind of see that there. So that's just to more decimal places, more accuracy. And what about your TI calculator? Again, I don't have an emulator yet, working on that. So you just type in menu, statistics, and here's the menu key. And here's you would scroll down here to statistic, and then scroll over, use this button, scroll over and go down to stat tests, and then we'd want to select a 1 proportion z-test, just like in GeoGebra. Once you do that, you enter your data, and I'll swing that down a little bit here. That's all right. So 0.407, 55, 150, it's not equal to. Hit OK, which is at the bottom of the screen, and it gives you the summary table. So this is a 1 prop z-test. We're testing our alternate hypothesis is not equal to the initial p. Our z-score negative 1.0055. Our p-value is 0.315 if you rounded it up. P-hat for our sample was 0.366 repeating, and we had a sample size of n. So we're ready to conclude it. Obviously, we've solved it 3 times with 3 different devices. But our conclusion would be, because the p-value of 0.3146 is greater than the alpha level of 0.05, we would fail to reject the null hypothesis and conclude that there is convincing evidence to support the conclusion that the proportion of students that have tried marijuana in Jane's school does not differ from the national average. And maybe that's too many. I mean, that's just the way I stated it. There's other ways to probably clean that up a little bit, but that's generally what it's saying. So we have reason to suspect that Jane's school is the same as the national average when it comes to marijuana use. And that is a two-sided one prop z-test. So I hope that helps, and see you next time.